When I see this symbol, I know that there are 35 protons, 45 neutrons, and 36 electrons. And I can tell that just from looking at this symbol. And by the end of this video, you'll be able to do the same for any atom or ion. You see, protons, neutrons, and electrons are the foundation for any element. And nuclide symbols are how you keep track of them. The issue is that students often memorize the fact that the center is the atomic symbol, the bottom left-hand number is the atomic number, the top left-hand number is the mass number, and the top right is where the charge is indicated. And this can often trip students up when they're dealing with different isotopes or different ions. So make sure you stick around to the end because I'll give you some practice problems that should help for your next exam. When looking at nuclide symbols, the atomic identity is indicated in the center via their 2 or 1 letter abbreviation. For example, we see that this is Ca, which indicates calcium. The bottom left-hand number is what's known as the atomic number, and this is going to be the number that you can find it on a periodic table. So calcium is the 20th element on the periodic table of elements. And what's important about that is that it also indicates to you how many protons this element contains. And the identity of an element that contains 20 protons is always going to be calcium. The top left-hand number is always going to be the protons plus the number of neutrons, and together they make up what's known as the atomic mass of an element. And this is because the mass of an electron is effectively negligible, and we only consider the number of protons and neutrons when calculating the atomic mass of an element. And this is so useful because we know that if mass is equal to the protons plus the neutrons, then that means that the total mass minus the number of protons must tell us how many neutrons there are for this element. So we've already indicated that this element, calcium, has 20 protons, and since its atomic mass is 40 minus 20 is 20, which means that the number of neutrons is equal to 20 for calcium, at least for this specific isotope. Now let's take a look at an ion nuclide symbol. Notice that there is a 1 plus charge indicated at the top right corner of this nuclide symbol. And at the top right is where you'll always find the charge. So in this case, we can figure out that there are 11 protons because the bottom left-hand number indicates the atomic number and also the number of protons for this ion. We see that the mass number for this ion is 23, and remember the mass is 23 minus 11 for the number of protons, and that will tell us how many neutrons there are, which in this ion there are 12 neutrons, because again the mass number is the protons plus the neutrons. Now remember, protons are positively charged and electrons are negatively charged. So if the charge is 0, then the number of protons must equal the number of electrons. Remember in the previous nuclide symbol, when we looked at calcium, we said that there were 20 protons and there was no value at this top right-hand side. And that means that the charge was 0. And in order for the charge to be 0 for calcium, if there were 20 protons, then there must have also been 20 electrons. But in this case, we see that there's a 1 plus charge, and this indicates that there's one more proton than the number of electrons we have. And since there's one more proton than the number of electrons we have, this will give us a 1 plus charge, and that must mean that we must only have 10 electrons for this ion. Now pause the video and try this problem independently, and then resume the video to check your answers. This is the nuclide symbol for a negatively charged ion of chlorine, and I know that it's chlorine because that is the elemental symbol indicated in the center of this nuclide symbol. I can also see that the number 17 is indicated at the bottom left-hand corner, which tells us the atomic number, which is where we can find this element on the periodic table, and also the total number of protons. So for this ion of chlorine, there are 17 protons. At the top left-hand corner, I see that the atomic mass is 35. And remember, mass is made up of protons and neutrons. So 35 minus 17 will tell us the total number of neutrons, which in this case is going to be 18 neutrons. Then, in order to figure out how many electrons, we need to remember that protons and electrons are oppositely charged. Protons are positively charged and electrons are negatively charged. So if this ion or element were neutral, there would be an equal amount of protons and electrons. However, since there is a 1 minus charge for this ion of chlorine, then we know that there must be 1 extra electron compared to the number of protons. And therefore, this ion must have 18 total electrons. If you check the description, I have thousands of practice problems that you can check out to help you ace your chemistry class. Drop a comment down below if you have any questions related to chemistry, and make sure that you subscribe to the channel so that you never miss out on another video. I'll see you next time.